the Lord be with us. Now the topic is data collection methods for scientific analysis and valid decision making. Looking at this topic very well, there's a link between data collection methods. Now the topic is data collection methods for scientific analysis. Hello? Now, data collection.
Yeah, we are hearing you. Go ahead.
Okay,
we're hearing
okay. I'm hearing what it's like. My voice is re-echoing. That's why I want to ask whether there's something there that I need to correct. Now, data collection methods. I was saying that it has a link with scientific analysis and the decision making that I want to make. That is valid decision making. I want to establish this that without good data collection method for a particular research, we can't make a good decision. The decision we are going to make eventually will be invalid. Though people may not know. In fact, we might have done a lot of things and people might have clapped for us. But later we know that that decision we made was wrong. And that's why we have to be very careful the kind of data collection method we're going to use for our research. Well, anyways, it depends on the type of research we are interested in doing. And we cannot talk about decision making until we have used the right tool, until we have used the correct, we have done the correct scientific analysis. Those are the statistical tools. But then we continue, we see some of these. So I may not be able to go to detail, but I realized there are some people that told me that they want to join this. So I want to be as elementary as possible. Those are not professionals and they want to gain from this. Now, these are the things I want to follow. These are the topics as outlined in the table of content. Introduction, primary and secondary data collection, mobile data collection using Kobo Collect.
Dr. Ajao, please.
Yes, sir.
Your slide is not showing.
Is what?
Your slide is not showing.
Oh.
Yeah,
was it showing before?
It wasn't showing. We are only seeing your file open. PSSN, webinar 3, webinar house, and all that.
Yeah, so please try to work on that so that we can be seeing what you are presenting.
Okay. Let me stop sharing and share.
Now it's good.
It's showing now.
Yes.
Yes. Okay. Showing now. Showing.
Okay. So what you have there, you should have data collection methods. That's the first slide. Methods for scientific analysis and data decision making. I mean, valid decision making. So as I've said all this before, but only for you to see what I put there. Now, I have said that there's a link between data collection method and valid decision making. In life, we make decisions every day, even this morning, even the fact that I'm talking to you now, it was a decision I made that I'm going to do this. So I must have collected my data, done this, done that. Without doing how do we move the two together? Data collection method. Then how do we put the two together for us to have a good decision making? Because you must make a decision after you have collected our data. That is the basic truth. When you collect data, eventually you do analysis, you do this and that, you must take a decision because that's the end of the road. And the decision has to be valid because either for yourself or the person you are working for or in an organization or even the research that you normally do, is it for MSc or BSc or PhD or the one that's given to you by somebody else, it has to be valid. So it has to go through. So this topic, I will mention some of, you have to go practical a little bit so that you know how to make valid decision before we end it. So I want to use this table of contents, introduction. I'm already introducing it, primary and secondary data collection. Then mobile data collection using Kobo Collect. Analysis of survey data involving like CAT scale. Then data-driven decision making. Now, what is data collection? It is the process of gathering information to analyze and make a valid decision. See, I want to analyze this valid decision. Very, very important. Now, data collection is a process of collecting information from all the relevant sources to find answers to the research problem. So test the hypothesis and evaluate the outcomes. It must be divided into two categories. We all know secondary method of data collection, primary methods of data collection. There are a variety of different data collection methods that researchers can use to gather data, while every method has its disadvantage and drawbacks. Now, this is just the summary of data collection we have. There are many. It depends on different fields we have. People in science may not use the one that and somebody else is using. There are ones that they are using that I will not use, but it has to be the one that's going to give us a valid decision at the end of the day. So we have this categorized into two. You can see secondary, primary, then where we have all of these documents. The observation, under primary, we have observation, we have interviewing, questionnaire, mail questionnaire, structured. It may be structured. I will talk about it in detail by the time we move on. Now, primary data collection. We have qualitative method. Primary data is the gathering of when it is we are collecting it from the source. That will make it primary. It's a process of collecting the original data collected by a researcher for a specific research purpose. It could be further analyzed into two segments: qualitative research and quantitative data collection. So the qualitative research method of data collection do not involve collection of data that involve number. You just something you can access. You can just look at it and write something that you are getting your data. Not necessarily using the proof, or you are measuring using a measuring device. So rather, it is based on non-quantifiable elements like feeling, emotion, to collect data from your kitchen, whether your soup is okay or not. At times, you just let this is it has this, it doesn't have that, whether it has onion. You're already collecting data. It's qualitative. For you to know that there's somebody is a male or female, we don't need to measure him or her. Just look at the person and say you are a male. So, and an example of such method is an open-ended questionnaire. Yes, we talked about this later again. Open-ended questionnaire. Okay. Now, qualitative method. This is just the diagram I want to show to us to just summarize it. Qualitative. So we're talking about the quality of such an item. Now look at it. We have in-depth interview. We have online forums. We normally do that. There are people that have collected data in Nigeria that have never been to Nigeria through online groups, web survey chats. The internet, the ICT has made it so easy for us to get data, qualitative data, without going anywhere. It has its own demerit anyway. By the time we get there, we'll talk about it. Then primary data collection, qualitative now. The quantitative method is still under primary data. Well, the reason why we're talking much about primary data is because we consider in statistics as the most reliable. Though there are times that we have to go, no matter what we want to do, there's nothing we can do except to go for secondary. When we talk about data that are already in record, and we don't have access to it when we are collecting it, we are not there. So at times we have to go for secondary, but ideally, primary data is something because of its reliability, and we know the source. So we have quantitative aspect of it. They are presented in numbers, require mathematical calculation to deduce, because this is where we do our standard deviation, variance. It has mathematical calculation. So it has close-ended question to arrive at figures to be calculated mathematically. So methods of correlation and regression mean mode are done. At times we are surprised when you see data that are collected through other means, and they'll be telling you this is the mean, this is the variance. And these are people that you cannot even argue with, but you know what they are doing is wrong. And that's one of those things the reason why we are doing this seminar. Okay, quantitative methods. Now, face-to-face, you can get that through online also, because you can measure it. For example, if you have ages of people sent to you, or you have access to you also participate. That's why I made mention of, I'm going to mention some method of collecting data through interview that are very, very reliable through online, without moving away, without even going to that place. And it's going to be authentic. It's only that we are not seeing the person, but the person will give us reliable results. This is quantitative, measuring. Now, secondary data now.
Go on, get a Bible.
Hello, sir.
Go ahead.
Okay. Secondary data collection, on the other hand, is referred to as gathering. I've been mentioned of this. Second-hand data. Second-hand, just like Atokumbo, you don't know the last person that used it anywhere in the world, that's just brought to Nigeria, and we bring it home, we begin to visit as new. But something, that's why by the time you continue to use it, you will now begin to find out that there are some faults, because you're not you didn't see it from the where it's produced. So that is how, if there's something you need to guide very well in statistics, data, you must know source of data. Data has given a lot of people problem in their research, and they have to go back to the beginning always, because the data is erroneous. So because it is second-hand data collected by an individual who is not the original user. So the process of collecting data that is already existing, be it in published journal, books, journal, online portals. It's not every data we see online. I will say this here. It's not every data you see online or in books that is authentic, that is original, or that is reliable. Let me use that word. That is reliable. So we must be very, very careful. Those that are listening to me here, that you are not just hearing data in here, you grab it, you use it. I can sit down in the corner of my room now, and all I need is just to get a portal, a site of my own. I begin to doctor data, send it online. People will see it and very happy collect it. It may not be reliable. So that's one of those things that's common with secondary data. Though there's something you can do, many of us still use it, but make sure we do a lot of things on it, so that at least a little bit reliable. So previous research, official statistics, mass media, diary, and so on. Those are sources. So importance of data collection now. Why are we even collecting data? The topic is data collection to make a valid decision. Why are we collecting it? See, there are a bunch of underlying reasons for collecting data, especially for a researcher. Walking through them now, I just gave these few ones. Integrity of the research. But when you don't collect data, you can't just sit down somewhere and say, this is this, this is that. The first thing they will ask you, where is the data? Then they will now tell you the source of the data. So it's very, very important we collect data. So it is for the integrity of the research you're presenting. Then reduce the likelihood of errors. We do a lot of comparison when we collect data. You can collect. That's why some people in their research they use all the methods. Use primary, use secondary, even under primary, they combine qualitative and quantitative, so that to make sure that they reduce likelihood of error. So decision making now, which
Dr. Jao, we cannot hear you.
yeah, I'm back. Now, I was talking about, sorry for the interruption, the internet the disturbance. Now, I was talking about the importance of data collection. So integrity of that, we have mentioned this. Let me move to the next one. So data collection methods and tools for academic research now. We have the interview method. Under that, we have structured, semi-structured, unstructured. We can have it structured, where we have already outlined what we have predetermined the kind of question I'm going to be asking. That is structured. Semi-structured, we missed the two. Unstructured is when it is totally open-ended, like our reporters, many of them don't, where there are some that are structured among them, when they want to interview you on a particular topic. And our students also go to different offices, to companies, to ministries, to ask questions based on the topic of their research. So they have to predetermine the kind of question they're going to be asking. That is structured. When it is unstructured, is face-to-face, and you are just asking the one that comes to your mind once it is relevant. So we get good data from interview, questionnaire also, from reporting here and there, existing data. Now, observation. Existing data, that's one of those from you want to consider a secondary data. The observation, just look at it and write whatever you want to write down. Mere looking at it is collection of data. Online tools, I mentioned Google Form, SurveyMonkey. SurveyMonkey is online. We all know Google Form. Time not permits me to be showing us, and we only mention the one, okay? We only show us there for Google Collect. Google Collect, SurveyMonkey is online, Google Form is online, they are all free. Though there are some, if you ask if you want to go pro, come and register. Then you pay some amount, the two amounts, then you'll be able to have access to what you want to do. That is not among the one that is free. Google Collect, very powerful online tool. You download it on your phone. One, it has a very main advantage. You know, there's a major advantage that it has over Form Plus, Google Form, SurveyMonkey. It has some tools after you might have downloaded it on your phone, and anywhere you are, it shows it has GPS. It gives you the longitude and latitude of that place. So if you are sending people to have to go and collect data for you, it will reach the location. Whether the person is sitting in his room and writing something, and you will know. So it's a very powerful online tool to collect data for academic research. So now these are data collection tool for interview. Camcoder is there. We have a reporter using this. So this one can take both audio and video. Then we have this one of data collection tool for interview, digital camera. Some people cannot, they don't have time. Why interview is very important. Some people don't have time to be filling a questionnaire. And it's based on the kind of work we are doing anyway. You are asking them some questions, you give them interview, you are giving them questionnaire, they will just take it away. Of course, they can't wait for you. You cannot wait for them also, they are on their way. But by the time you see interest in you and you see them sitting there somewhere, or they are waiting for something, the kind of question you must structure it, they ask. Then you have digital camera also. Digital camera is just to take the picture. Now, this one is audio recorder. This can be in our pocket, and when I'm talking, to be recorded. It's just for this work alone. This is what this gadget is meant for, audio recorder. We are collecting data through audio recorder also. Then I made mention of Kobo Collect. It's an app. World Bank, WHO, IMF, all of them use this. And it's very, very powerful. By the time this is how to do it, and I'll just go through, take us through how to do it, because we're talking about data collection. Now, whatever thing, this is like, you must have structured the question you want to ask, and you must have registered everything. But the first thing is to go and download it. Just go on your phone, your mobile phone. All you need is to just go to this place, Play Store, download it. It's called, just look for Kobo Collect app. Then this is step 2. You see it here. Then here you install it. After installation, here we now accept. Then from this place again, you click on it. You see all this form come out. Then you go to, you can see general setting, general setting, admin setting. Then the general setting, you pick on it. You are going to have all of this fill blank form. edit save form, finalize. So there's a central database. That's where all the people you have given this work to do, as they are sending it, is entering that database. The location at that time. But you must have said the question. I've tried all of this. This is, for now, to me, from this place, is the best. In fact, it has so many advantages, especially that of a GPS that it has to tell you the location. And whether now, one advantage it has again is that you can use it without internet. So anywhere you are and internet comes to your phone, the thing goes directly to the database. So it's a very good, it's a powerful tool to collect data. But the first thing, you are going to create accounts, all of this is set up. I want to quickly talk about this and leave it. Then if you are interested, you can just go through the steps. I'm going to drop the copy of this with the host. Now, after you have done all of this, we need to know the methods, because we cannot do this seminar when you're talking about making valid decision. We cannot just go ahead and begin to talk and leave it. Before you make good decision from the data you have collected, believing that you have collected good data, not falsified data. There are tests we need to do. It depends on the kind of where we are coming from. People from Agric now want to go experimental design, because the models, the kind of thing they do, they want to see the effect of fertilizer on a kind of maize, that kind of data, and they have continuous data. We're talking about continuous data. It's not data you are going to be collecting through Kobo Collect questionnaire. Though at times they combine that if they want to interview the farmers, but this it has to do with measurement. It's a continuous. You're going to have continuous variables. So in that case, if you have weight of maize A, weight of maize B, and you want to see whether there's correlation between them, you use PSSN correlation. And because you want to make a good decision, then this is PSSN correlation. There are so many, many of them. I just pick these common ones. PSSN correlation. So people that are listening to me that are not, they just use PSSN correlation anyhow. No, it's used to test for the strength of association between two continuous variables, not two continuous categorical variables. Not two categorical variables. If a data is categorical and you want to test for relationship, it is not, there's a way you can test for relationship that it is not PSSN. Do we say, oh, I need product movement correlation coefficient? No. So even we tell you, okay, help me handle this data. This is what you are going to use for me. My professor asked me to go and use this, and the professor is not a statistician, and you will see this thing is wrong. And that's why when this topic come up, I say it's an environment to explain some things. So spearman correlation, it tests for strength of association between two ordinal variables. So this one does not, you can see in brackets, does not rely on assumption of normality. You see, because the first one rely on normality assumption. But this spearman is just like it's part of a non-parametric study you normally do. So chi-square also tests for association between two categorical variables. Categorical, okay. Smoking, for example, having cancer. So you can do those two variables are categorical, and you have it one maybe the way you are able to arrange it. You know the data, the values in each of the variable are not continuous. It's categorical. So we use chi-square here. Though it's being looked down, you say, don't use chi-square for me. Go and use this. We should allow the data to talk. It's the data. In statistics, we normally we diagnose data. We diagnose it. Just like when you go to hospital, you don't tell us the man in the hospital, the nurse or the doctor, oh yeah, I want Fensic, I want Panadol. No, it is we normally carry out tests on our data. When we carry out the test on it, in fact, carrying out various tests on data types takes days before you now say, okay, this is what I'm going to use. So many of us today, we just dive into it, just go into it because we are in haste. We want to get results. And one thing with all this software we are using is that anything you put in is going to give you results, whether it's right or wrong. So it is we need to know all these simple things. Now, the simple regression tests how a change in predictor variable predict
Please, those that are on video can help us to stop the video until the question time. Thank you. I'm sure Dr. Ajay is having a network glitch, and that's why it's going off and on. We soon have it.
Hello. Hello. Hello.
Go ahead.
Hello. Yes, sir. Now, so as I was saying, we have to know this classical test. There are more than this. There are more than this. I just give us these few ones. Now, survey data involving Likert scale. For our people from field and discipline where they rely on survey data, we have different kind of Likert scale. So this is just 5 points Likert scale. We have 4. When you have 4, look at this, for example, on satisfaction. If what you want to collect data on is on satisfaction, maybe the work you are doing is maybe you're satisfied or not. The first one, the weight, the lowest weight should go for the one that is negative opinion, negative perception, very dissatisfied. People have seen cases where people will go and allocate the one with the heaviest weight to the one that will give negative results. Like very dissatisfied, you go for number 1. Then dissatisfied should go for number 2. Then the last one, very satisfied, should go for the heaviest weight, which is 5. The same thing goes for all of the remaining one. Agreement. This is the most common one we normally use. Agreement. Strongly disagree. You can see for 1. That's why when you use a wrong weight allocation here, when you allocate 5 to strongly disagree, I'm talking from experience. I've seen cases like this. The result will now make you to go back to how the person did it. This has caused a lot of errors, and you can't take a valid decision according to the topic of this webinar. By the time you do a wrong analysis, that's why I say not just collecting data. The analysis you are doing also will contribute. So otherwise, you're going to be making either you commit type 1 or type 2 error. You're going to be getting a hypothesis that is correct. So the same thing goes with the remaining one. There are so many of them here. I just give us these 6. So then tools for analyzing survey data involving Likert scale. We have log linear model, and you can use R, you can use SPSS, you can use JUMP. We have relative importance index. That is ordinary macro execs can handle that. I'm going to show us this. One-way contingency. The one that is very common that we normally do is that of 2-way, where you have the column and the row. But when it comes to Likert scale, using any of this, the one that will give meaning, that is scientific, is 1-way, because it is the perception or opinion. We are analyzing frequencies that work here. It's not just using anyone. You can't use the simple linear regression here. It's not that it won't give you results, but it will be not correct, it will not be correct. So now exploratory factor analysis, we use R and HIMOS here. AMOS is an analysis of movement structures. I'll talk about it also. I want to demonstrate it. Now, exploratory factor analysis here talk about when you have a lot of items, you have a lot of variables, maybe factors contributing to a particular response, and there are too many. We need to look for how to reduce. We need to reduce the dimension. It doesn't reducing the dimension. The one we normally use when it is we normally use principal component analysis. This is what this one does for Leica scale for survey data. So we call it EFA. Then we have CFA, that is confirmatory factor analysis. R and AMOS are handling this efficiently also. Then we have the popular structural equation modeling. R does it. AMOS also does it. I'm going to show us how AMOS does that. Structural equation modeling, what it does is comparing, is finding relationship among items in our questionnaire, or a particular response variable. For example, now, performance of students in school. It has a lot of determinants. What determines performance of students? We have condition of classroom, relationship with the teacher, the hostel, even at time, background. So when there are too many, you want to reduce the dimension, and you want to see the relationship before you even to know which one to not allow to be in the model. It is structural equation modeling that does that. And it's going to show us graphically. We call it part analysis. It's going to show us the part of the model by arrows. So here, we want to visualize categorical data. We also have categorical data. This is common with people in biostatistics. How do we categorize? How do we show it? For everything we do in chi-square, you want to show what we do, want to visualize our data in chi-square. For example, look at this. This is something I did 2020 till now. I just submitted the paper. This is a research carried out on our campus. Use of face mark and whether it has any relationship with the school, that is faculty, where the students are coming from. Those that comply with use of face mark, there are two: social distancing and face mark. Does the school where they are coming from has anything to do with it? You can see from SOE, School of Engineering, SBS, School of Business Studies, SES is School of Environmental Studies, SOS is School of okay. Now let's continue. We have this one. It continues here also. We have for face mark. We have always. We have never. We have sometimes. Now, how do we show this graphically? So we call this one mosaic plot. I think Dr. Yamakishu mentioned something like that when he was talking about the first about it in the first presentation. Now, this one shows the frequency inside of it. You can see also. Then this one is just the visualization of categorical data. This one alone goes a long way in our research. It's not only when we write p-values and taking decision. We can take decision from this place because this is already showing it to us. This p-value showing here. P-value is here also. That's mosaic law under categorical data. Now, visualizing categorical data again, we can use balloon plots. All these one are carried out using R. When you want to use R is a software also that R and MATLAB, because there's no way you will use somebody that has been using MATLAB won't find it difficult to use R. Just for us to make a valid decision after we have collected our data and we have done analysis. Using statistical inference alone, all the significance is no longer enough for our research and for our publication. We need to put charts, diagram like this, so that somebody does know all that that is not a professional in statistics. Seeing this alone, though at times to interpret this, you need to do extra work, but it's very easy, at least because it's in picture. Now this is balloon. The one that have the one with bigger shape, that is the round, has the highest frequency, and that is about balloon plot. Now let's move on to relative importance index. We call it RII. still on how do we analyze opinion of people? Because not to deceive ourselves, hardly there's any research today that will not ask of people's opinion unless it is pure academics. Even academics, at times we go on to ask people about what we are writing down. What is your opinion about it? But this is what can link we and the profession and people outside. If what we are doing on our papers doesn't have any meaning to people outside, they will believe we are doing anything. So we need to know how do we analyze people's opinion, their perception. So relative importance index is another powerful tool. They are a useful alternative to multiple regression. So they are mostly used when dealing with variables obtained from surveys, especially qualitative data. So the contribution of each of the factors to the research question can be examined, and ranking of the attributes is in terms of their criticality. That is how critical. So there are some people that will give opinion. The opinion they are giving, the opinion that you are writing, that you are putting down, whether we like it or not, is what's going to determine your response variable, people's opinion. So now, and that's why advanced country, before they even, after they have agreed, or the president has told, they have taken it to the house, they still listen to people's opinion before they now take decision. We're talking about valid decision here, whether scientific decision or other type of decision, whether political, even at home. We need to ask our children at times what they like. Otherwise, we just be giving them what they don't need. So the same thing with all the research we do. So relative importance is very important to be used. I'm going to show it to us here. How do we go about it? This is RII. What we have here as summation of fx is total weight given to each attribute by the respondent. Imagine you have distributed your questionnaire or interview, because there are times we combine interview and questionnaire together. As you are asking the person, somebody is writing it down for you. So whether you combine or not, we want to use this. Now, total weight given to each attribute by the respondent. Then summation of F is the total number of respondents. So the column for summation of F will be the same. If you distribute 100 questionnaire, the column for summation of F must have 100. But summation of Fx, because the weights are different. If somebody pick, for example, strongly disagree, another person now pick agree. So the weights are different. Agree, we go for maybe 4, because strongly agree is 5. So how will the person, how will we have, we can't have the same column total here. But this one will be the same thing. Then K is the highest weight on the Likert scale. Here it is 5. The one we're going to use for it is 5. The reason why there are some people that don't like using 5. I mean, 5 points Likert scale. It gives room. The reason why they don't like it is because it gives room for people to pick neutral. By the time you are for example, you administer your questionnaire to 100 people and 50 pick neutral. What kind of analysis are you going to get? So me, I'm of opinion that we should even remove neutral. But in medical and some people in psychology, they argue that it has to be there because you can't force them to pick. Even in politics, you can't force them to pick the opinion they don't want to pick. Otherwise, they won't pick. But the disadvantage is that by the time very large number of people pick neutral, it will not be favorable to the result of your analysis. Now, RII table of result. This is an example. Now, for example, a factor affecting student performances. You have collected this data using questionnaire. You use SPSS, you use R, you use whatever. Now you want to use RII. I'm trying to work on this kind of tool. Up to now, I've not, if anybody wants to help me to write program on it, so that you'll be able to do it on her. For now, I'm still working on it. How do we do it on her? But let me explain how it's done on Excel. This is Excel. These are, for example, now, factor affecting student performance. We have poor library. These are identified factors. Poor hostel facilities, inconducive classroom, poverty, poor background, and so on. Just an example. And summation of F, go back to that question. The way I've given us the formula. You can see summation of F is total. This is the total number of students on which we administer the questionnaire. So now, one, I didn't use 5 points scale here. I use a 4 points because of that reason I gave. I don't want anyone to say to pick neutral. So it's just strongly disagree is 1, disagree is 2, agree is 3, strongly agree is 4. So in this case, the highest decay here is not going to be 5, it's going to be 4. Now, by the time you now add all of this together, so how do we get this 4? This 4 here. The total number of people that pick strongly disagree. When you multiply it by 1, you give us this. Total number of people that pick disagree, multiply by 2, we give us this. That is what we have here. Then here, multiply this, each of these, we give us summation of fx here. Now, summation of f is just addition of this. Then the mean is dividing this by this. We're going to have this. The RI also give us this. How do we take the decision here? We must take decision. We are talking about making valid decision. Though here, there is no lay down rule that they are rejecting setting up hypothesis that you reject your H naught once your p-value is less than level of significance alpha. No. There's a rule of thumb here that once the RI is less than 0.6, then it is not a good contribution to factor affecting student performance. But all of them here, you can see all of them above 0.6. But we can rank them. In Excel, it's very easy. Just write a simple program to rank all of this, even if there are 20 to rank. Just pick maybe the first 5 or the first 3, whichever case. So we can see this, the one with highest RI contribute most. Poor background contributes most when it comes to factors affecting student performances. According to the person's research, this is just an example. Now, talking about structural equation modeling. Here, this is where I don't want to say, well, let me say it's more advanced than this. Because this one, we're going to use AMOS. AMOS is analysis of moment structures. It's a statistical software. It comes with IBM SPSS. But this one, the one I use is Factor 3. I tried this on her also, give me the same results. But when you are teaching people that are not in our profession, we have to look for something that is very easy for them so to appreciate our work. So I find out that even people outside statistics, if they are looking for a way of doing this, they know what they do, what they want to achieve, but they don't know how to go about it. AMOS is very easy to use. It's an added SPSS module, and it's especially used for structural equation modeling. What do we do in structural equation modeling? We want to see interrelationship among our variables, though we can have response variable, like the one I just mentioned now. Response variable here will be student performance. These are factors. So it means we must have data for response variable, for student performance. So these are the independent variable, so to say, factors. Now the same thing here. This one will show. This one cannot show us any charts showing the relationship, but this will show us how the relationship among the factors. Does poor background has anything to do with poverty? Does poverty has anything to do with poor hostel? Because some students can go for hostel outside the campus. So poverty also has relationship with it. So this will show everything. Structural equation modeling will show it. Either you use R or you use AMOS. Now it is also known as analysis of covariance or causal modeling software. There's no name for it. What we call items, these are items in questionnaire, but some people call it constructs. We call it constructs. The same thing. Now look at example of SEM, because you want to make valid decision. Do not forget the topic. Do not forget the topic of this webinar. We want to make valid decision from data collection. So we should use the right tool for our work, not just using anyone. So SEM, this is structural equation modeling path diagram. It's an example. This one I did, and I would like to show it, something related to it before we go, time permit. It's part of the plan. Now, this path diagram showing, using AMOS. What we see here, I want to see if I can increase it. I see. Yes. This SP, this is I see SP1, SP2, SP3. students' performance. You can see all of these are all factors. I identify 11 factors. All this one we see here, they are called unobservable variables or values, which we call errors or residuals in our own time. They call it unobservable. You of course can't observe them, but they exist and they must be estimated. Now, you can see the data-driven decision making now. Any decision you want to make must be data-driven. That's the whole truth. If we are making decisions without adequate collection of data or data collection that goes through a reliable method, it will not be the decision we are making from such analysis or data collection will not be valid, and it can be queried. So data-driven decision making, that's DDDM, is defined as making decisions based on hard data as opposed to intuition, not just intuition, observation, or guesswork. The value of data-driven decision is dependent on the quality of the data and its analysis and interpretation. Otherwise, error setting, I've mentioned it the other time. We have two types of error in statistics. We have error one, type 1 error, type 2 error. That one is found in the error table. Every decision we make should be data-driven. I've made mention of it the other time. When you make decision, just collect data, just use anything, and you get results. Because one thing with what we do is that if somebody in the UI handle this, we are handling the same data, and Dr. Yamaka is handling it in University of Ibadan, and Dr. Garba is handling it in University of Ilorin, I'm handling it in Nadu, somebody else is handling it in Texas. We must arrive at the same results. If we are doing the right thing, we must take the same decision. But the problem starts from data collection. What kind of tool do we use? Then what kind of analysis we carry out before we now make our decision? So every decision we make should be data-driven. So some practicals now, I want to go to some practicals. I want to show us what I've done. I will do it again, show it to us that it's not difficult. We only need to show our interest in it and have the mind of doing the right thing. So login, I want to show us how I carry this one out in our log linear model. The relative importance index, which I just talked about now, using Microsoft Excel. Then the CFA, that's confirmatory factor analysis, using IBM. Same thing as this one is under the structural equation modeling using EMOS. Thanks. So I want to go to, I want to make use of this, the log linear now. Okay, sorry. Okay. Can we see my screen now? So, yeah, can we see it? Hello? Hello? Hello?
We can see it.
Okay,
We can see it.
Okay. Sorry, I was looking for where I minimize the
But
window.
it would be nice if you can change the color so that we can see properly. It's too dark.
Okay. Okay. Let me go to. Whereas
You can leave it like this. It's big enough. So,
it's okay.
yeah, I think it's okay.
Ah,
If it's
all right.
big, it's okay. We are not hearing you again.
Hello.
Yes.
Can you see the screen?
We can't see anything.
Okay. Can you see it? Hello.
Yes, we can see it.
Aha, sorry. Now, just let's look at it as very well. It's just, I won't waste time here. So this is log linear model for continuous table. You know, I was talking about categorical data during that time, and I've identified log linear. Now I try to write something here. So these are the libraries we need, just like the packages we need to use to achieve our aim. People that Python use and what I'm talking about, they use pandas there, but in how we use library, these are the ones we need to install if we are making use of R for to carry out analysis on log linear. So we need all of this. So log linear models can cell count in contingency table. They are a little different from other modeling methods in that they don't distinguish between response and explanatory variables. So now I want to quickly, if some of us that are familiar with people from biostatistics, there's this book that's very popular, Agresti. That's categorical analysis by Agresti. So there are some examples there also. So I'm making use of this, and I want to show us the one I did. This is it here. That result I showed to us when I was explaining the slide about the use of face mark on our campus by the students. You can see. Now I want to show it to us how you can carry this one out using R. You need to create contingency table. When you collect data and you must show it to people. We have gender. Does gender determine use of face mark? Because we want to take a decision. We're talking about data collection and taking valid decision. Does it affect usage of face mark on campus? I consider that. I also consider the school they come from. All of this I did. But the first thing to do here, after you have installed all of these libraries, you have to remind R. That is by loading them. Can see loading. Do I use this one? It's trying to load, because if you don't load all of this library, none of those code will work. You are asking her to make use of them and picking them from the libraries. They are all packages. We have thousands of packages in her. We only make use of this one, the one that's peculiar, or they are relevant to what we want to do. All of these have what they are doing. Now, I now go to my code, all of this. Then I want to bring the data in. Data, I call it facemark.csv. So there's a way you can use SLS also. They are all Excel file, facemark.csv. Then I want to bring it forward here. Just click on it. Now, these are the contingency table that I need. I can show to us how the data look like in Excel, the original data that I have in Excel. I will show you to us later. So we have this table, command table. We break all of this into 2 dimensions, picking one and the other, 2 categorical data. You can see face mark, that's the use of face mark. People that use it always, people that use it, that never use it, and people that use it sometimes. These are students. We want to compare face marks usage and gender. Does it have anything to do? Do they have any relationship? The relationship here will be, the null hypothesis where will be gender affect usage of face mark, or gender and usage of face mark are related. So that's just going to be the hypothesis here. You can see I've not done any analysis. I just try to show us how it looks like. Then we want to create the mosaic plot, which I showed you that time on the slide. So we create the contingency table. If we have not created it, there's no way we can do that. So we have to attach. People that have been using R before, there are ways we can bring your data to R. It just depends on the one that is easier for you. We want to recall the data you have brought. I call that data face mark. So we want to attach it here. I may not use attach. I can just put a comma here and put data equals face mark. It's going to give me the same thing. Now, you want to compare gender and face mark in this table alone. The one I did here is just for all of them. This global one. But the one I want to do here is just, I want to isolate gender and face mark alone, which is giving me something like this. You can see. So it is better presented this way. This is what I want to focus on. Then face mark used by gender. This is it. Now using mosaic plot. The one I showed you that time there. How do we go about it? You can see mosaic plot. This one is gotten from one of the libraries I earlier installed. This is it, ggplots. And which of them again? There's one again. Is here. I think you want to look for it. I've installed it. That does that work. It's another. It should be up there. That does that work. So if you don't install all of this, will not give you your results. That's flex table. Flex table with that and mass. That's what's giving us. So all of them have their own role in the analysis. So let me now plot this. You can see these are the results. These are different kind of mosaic plots we have. And we can see the p-value showing to us here that face mark and gender are not, they don't have any contribution. They are not related. Gender does not determine whether somebody is going to use face mark or not. This thing happened during the coronavirus era. So look at what I use here. Now, you can see the code. Now, if I want to change this, if I change this, I can change this one to another plot. I'm going to show it to us later here. Now, by social distancing alone, does he have anything to do with gender of the student also? Yes, you can see. Now, this is your table. Now, I want to see the mosaic plot. Mosaic plot, this is it. So, social distancing and gender are also not related. You can see. Now, if I'm want to tell you, if you carry out your analysis on this using any of the inferential method, you are going to have the same method. You are going to have the same result. Now, by school, either you come from engineering or from environmental, from school environmental or engineering, you are going to see. Now, this is a can see face mark and school. This the contingency table. Now let's see the mosaic. You can see. This one shows that people from engineering that they have the highest number of students that always use face mark. That was then. And it's showing that it's significant here. You can see. So here, then by social distancing, the same thing. Let me quickly go down, go over time, and see the one I did for the inferential. This balloon plot. Before that, let me show that of balloon plot. Sorry, I have to show the three way that shows all the face mark usage by school. This is face mark usage by gender, by social distancing, and by school. This 4 shows that somebody that use face mark always is a female and doesn't keep social distancing, and it's from School of Business. That is SBS 4. People that never use it here, the same thing I'm going to do the interpretation for all of them. But there's one I did that even shows all the frequencies. I will show it to us that shows all the frequencies. This is it. R is very easy to use when it comes to manipulation of data like this, which we are going to be struggling with some other software. All we need to do is just take our time to sit down and understand what we want to do. You can see gender, it has brought everything together. Look at gender, social distancing. Look at school, face masks. This is 372 students that were given questionnaire. You can see female, no, that is no keeping, the person was not keeping social distancing as from School of Business, and use face mask always. 4, can see. By the time you see all of these, then you're going to have detailed, total number of students that were interviewed. So balloon plot now. Balloon plots. Balloon plot is giving us this. This is it. The one I showed you the other time. And you can, it just depends on the one you will know that suit our purpose. All these ones are under categorical data. You can't use all of these charts for continuous data. We should know, because we're talking about data collection and making valid decision. We should use the right tool. If it's continuous data, we'll not be talking about this. We'll not be talking about this. We have to be testing for normality here and there, and we must use the relevant chart to show that also. Multiple bar chart. You can use multiple bar chart for this also. I've done all of this here, but let me just show you some of them before I go to the model itself. So this is it. Social distancing by gender. You can see number of students. See, so all of this we cannot. These are just supporting when you go to make valid decision. We can't use chart alone to make final decision. Our decision has to be based on rules, p-values. Are you going to reject your H naught? Are you not going to reject it? But diagrammatically, people should know what you are talking about by this. And I know from what I have seen before, a lot of people, even to what they have done to get the highest degree they have today, doesn't go beyond all of this thing. People that do this thing have done business on this matter. What they do is just chart table. They don't really go into much of our statistics. So that's why we are explaining this. And we need to use the right tool. This by social distancing, this by school. Let me just show one more before I go to that one. Let me just show you one more. So this is it. This is what we call component bar chart. Component bar chart. So here we can see what we have as multiple bar chart the other time here, that they have different one by the side. They call it sidebars. This one is not sidebars. All the bars, can see all of the schools in the same. We normally do this thing in Excel, but there are so many demerits of Excel when it comes to charts, when it comes to graphics. That's why I say how MATLAB. When it comes to graphics, I don't think there's any other software that can match it. Well, Python is also trying. So you can see the beauty of this. This result of ggplot we use as one of the libraries that I installed. Then now I want to show the model of log linear. Here, there are so many models I constructed here, and I have to pick the one that is the best. What makes it the best? The one that has the least deviance. We use deviance here, not the other way around where I was talking about continuous data. This categorical data. So I want to show to us how I make constructed my model. The first one, I estimate for log linear model. I just use G here is for G here. Okay, we have F, we have G. All of them are here. So the S is cool, and D is social distancing. Gender is F. F is use of face mark. I've defined all of them. So here I want to estimate this here. Each of them here. You can see now, see the result. What I did here, I'm just after what is here. Look at residual deviance. The non-deviance here means that if you are talking about just the intercept. But residual deviance, you can see, is what we are using. The degree of freedom and residual deviance must not be too far. This is look at it, 127.37 on 40 degree of freedom. That's too high. This has compared the male and yes, okay, from SES, from SOE. Then if somebody is from another department of another school and is speaking yes here, what does it mean? No, this is like interaction effect that we normally do in continuous. When you are talking about the one we normally do is better design. We want to see interaction effect of a particular factor, combine them together. That's what this one is also doing here. So, and that has given us this. Now, I'm not okay with this. And I'll continue again to do the remaining one. So now the table of the result here is giving me here. You can see the result. Because after you have obtained your model, you want to use that model to do prediction. Does the prediction giving you something similar to actual value? These are actual values of frequencies. These are actual values. Add all of these things together, we give you 372 students that we interviewed or we gave questionnaire to. Look at what my model one, I call this mode one. This model one, fitted. These are fitted values. Look at them. This actual 4, fitted is 5.8. This fitted is not too far away, but you cannot just conclude here and say, look at actual. People that, male that pick yes from School of Engineering and using face mark always is just, they are 26 in number. But look at what our model is predicting for us. 15.8 is too far. The deviance here will be too high. So I need to draw another model, prepare another model here. Look at it. Various log linear models that I carry out here, they are here. Let me just load all of them for us to see. So now what I did here for mode one, these are various models now that I've done. All of them are here. I want to now see fitted value for log linear model. Each of them. Let me now load. I want to pick the one that's giving me the best. Look at observe. Now, these are 7 models. Observe. These are observe frequency. These are frequency from the feed, actual. Some people call this observe, some people call this actual. Now, I want to compare each of these models. These are the predicted values from each of these models. This one, model 1 is this. For model 2 is this. For model 7 is this. You can see one of them will be very close to it. I'm already identifying one. You can see this model 3. Model 3, look at where is predicted, where observe is 3, is 2.63, 64. Now, the last one, where others are predicting 10.27 for 9, observe value of 9 is predicting 10.27. This one is predicting 8.64. This will be very good model. This or this, you can see. So I can identify 2 models, model 5, model 3 from this. Now, we are making decision. For us to make good decision, we have to do a lot of things that will give us value so that If you are writing a paper from this, anywhere we are sending the paper, people will not just throw your paper away because you know you have done a lot of things. Now, how do you assess that? Through goodness of fit. Like I wrote something here. It can be seen that the third and fifth models, that is models, because all this GFD you see, I combine all of those factors together. I did comparison. So this model 3, this model 5 are close to the observed data. Therefore, any of them can be picked as a better fit for prediction. The other models fit poorly, although further tests have to be carried out in order to pick the model. So test of goodness of fit is this here. Let me, I don't want to be going to go like I wrote a lot of things on this. So let it load. Let it load. We see, okay, still processing it. Now let me do the remaining one by linking it to HTML file for us to see the results. It's going to process it so that I'll summarize that. Because I want to mention Amos before we finish this, before I end this webinar. I want to show us the results. It's loading it. I'm using our Markdown. So it's going to show it to us in HTML file. Okay. It's loading it. It's loading it. Sorry, I won't take time necessarily. So now all those things I've done. Can see everything I was saying at that time. I've explained all of this. I want to go to the model. So now, our Markdown will give us the result in PDF, in HTML. It can even give you in Word. Now, all these things I've shown before. I want to go to the one I made mention. Okay, yes, this is it. Can see the result here. So this, to talk about this now, you can see the fitted model here. I've explained this right time. This for model 1. So this is the one that gave us the 7 predicted values from different 7 models. Now the goodness of fit is this. So you can see now this is where I'm coming from. I mean, this is what I want to talk about. Now these are the models. You can see 7 models. These are the deviances. These are the degree of freedom. These are p-values. Now for the data on student mass, let me read what I put here. For the data on student use of face mark, larger deviance values with smaller p-value indicates poorer fit. You know, it's not like when we do regression, you now say H0, you want to reject H0. You want to always reject H0 because when you do not reject H0, it will not favor you because it means there is no relationship. But in this case, it's the other way around. We must have higher p-value here. So as a rule of thumb, we will like the residual deviance to be close in value to degree of freedom, as I've said earlier. The first model, that is model this, has this on 40 degree of freedom. This indicates a poor fit. So if it says that if we have insufficient evidence to reject the unknown hypothesis that the expected frequencies fitted value satisfy your model. So in this case, the best model will be the one that has the highest p-value. Here, that is this model. The 5th one, you can see, deviance is 17.416 on, you can see, degree of freedom 17. Though, 3rd one, I said at that time, you know, the other one I show us on this place, in this place, it's just visualization. You can't just say, well, this one, people are expecting significance, statistical significance, not just chart and this. Chart is just supporting. You must be able to scientifically prove it. We're talking about scientific, according to the topic. So it has to be scientific and must be backed up with statistical significance. So here, comparing model 5, we all know that model 3 and model 5, one of them is the best. But these are showing, showing it because look at deviance of model 5 and degree of freedom. They are very, very close, which is one of the criteria to use to test for goodness of fit of the log linear model. Second one we can be picked is this. 0.42 is the p-value for the 5th model, and the 3rd model is 0.144. So I want to stop here. Other ones, we have taken our decision here. We have said that model 5 is the best. I want to quickly go to relative importance index. We have collected data, we want to show that. I want to just to show it to us on Excel. Then I will now end it. Oh, okay. Let me stop sharing. Can we see this? So,
yes, we can see.
Can we see this?
Yes, we can see it.
Okay, so what I mentioned this one come under relative importance index I was discussing the other time. On Excel, we should start, a lot of us look down on Excel. When we say Excel, people look at you, how can you say use Excel but it has some powerful things you can do. The result is most important. I told you I'm still working on it. I can write code for it on because it doesn't have any package where you can go and download and begin to use. But this one, you can write it so that you just begin to use it on our. But for now, it's not there. So, but using Excel, look at what I discussed the other time. I said this one is strongly disagree, agree, and strongly agree. I've explained all of this before. I only want to show us how the code look like. Look at it here. See, ordinary things, writing small code on Excel. This one will give you your summation, and you're going to have the same thing here. Then here, summation here, you just multiplying this by what you have as weight here. The mean, ordinary, we all know that summation of fx divided by summation of f give us mean. Then R will give you the H3, which is this, that's the mean, divide by the highest weight you have assigned, that is 4, giving us this. So the ranking, you can see, you can also write a program for that. So that is how to do this using relative importance. And lastly, I want to talk about Amos. How do we do structural equation modeling using Amos? Some of us must have heard about it, but what interests me there is the part of model. Is the part of model. So I want to open it. I will open it and share. So now, can we see this? Hello? Can we see this screen?
Can we see it? You can see it.
Yes, yes.
Okay.
Yes, we can see it now.
Okay. Yes. Now look at this screen. Now I want to do something that it is Amos I want to use now. And I want to use an example of data that we have worked on campus. Through students project that we asked them to go and collect, though I didn't use all of this for them because they will say it may be too complex for them, but I took it further. Now, this is Amos. You're already here. Let me extend it. Right. Okay. Now, the first thing to do here is to go and look for your data. Select data, find name, look for where your data is. My data is in PSSN Seminar Training Committee, Webinar Resources, SEM data example that I just created for this. Then we can open it from, if I open this one, it will take me to SPSS. Let me open it, but I don't, this is it. So, so I want to now do some simple analysis on it. I want to test, I've said it that SEM, what it does is to show interrelationship among many variables. So the one that is the exploratory factor analysis must have reduced it. You must have reduced the dimension. You must have some have to go. You can't put all of those variables in the model. Now this one take it further again. Now to show the relationship. Now what I'm going to do here, you can look for the data here. Just okay this, okay it's okay. Then you now come here and show the data. You can see the data has come up here. These are the items. These are questions. You know, all the questions you ask under a particular group in questionnaire, they are called items. I said some people call them constructs, but these are the variable names. So this AC is a academic performance. HC1, you know, I want to see whether these factors, I mentioned the name of these factors, whether they contribute to academic performance or not, as I've mentioned in the slide. So I identified only two. There are too many variables, but for the sake of this training, I just pick two variables, two factors, and those two factors have their own names also. The first factor that contributes, that's determine academic performance that we identify is a austere condition. I call it HC, austere condition. So the second one, still under austere condition, no water, no electricity. The third one, too many students per room, things like that. They are under austere condition. Second factor that determines academic performance as identified by the researcher, we call that one classroom condition, CC. So classroom condition one, the one that too congested, two, no good ventilation in that class. Three, that's CC3. Maybe the chairs are not okay, things like that. We just identify four. What I'm trying to say is that two factors having all these under each of them. So four under each of the factors. They are called constructs. So now how do we show the parts? You come here, drag it here, click on it. See, the austere condition has four constructs. Click on it. One time, give you one. Second one, like that. Third one, like that. Fourth one, give you that. So, you are through with that. Okay, we can now move it because we are looking for this is just the first factor, having four variables. So we need to do for the second one also, but we can move this. How do we move that? Just go to this arrow. Okay, we have done this. We can move it by rotating this using rotation and drag it. Drag it. Let's preserve that and try and drag. So we drag this here. It's very easy to use a mouse. So we can see it. Then we can repeat the same thing again. Can repeat the same thing because we are having another factor, having four variables also. I'm going to click another one here. So 1, 2, 3, 4. So then you have to do the same thing here by rotating it. So otherwise you have to click on this so that it will not continue to rotate. So how do we move? You can move using this. So move. We want to expand this. It's too tiny. How do we do that? You can just come here, increase. Move them together. Move them together. We want to show relationship among these two factors that contribute, that determine academic performance in school. Now, we need to label all of this. This one will be, we just double click on that. So okay, I think it's better to put them from this place. Each one goes here, goes there. This one goes here. You are moving the variable there. And as you are moving each of these, the values are going there directly. That's one thing with it. The values are going directly with it from SPSS, where you have the data. For classroom condition, it's going directly there. is also going here. This is also going here. And this one is also going here. Now, the name of this factor, this is class, this is, what do we call this one now? I can just give it a name. Let me give it, this one has its own name. You can call this HC. HC. So HC, that's HC is hostel condition. Just write type HC. You can increase the size, the font size if you want it to be bigger. So the same thing here, do here, just double click, give you that of CC, that's classroom condition. I want to increase this to 20. That's it. You have seen it. Now, something must link the two. The one that will link the two is the dependent variable. This is academic performance. So we have to create another thing here. We create this here, create it here. So creating this here, we now move the value, the variable inside of it. So these are errors, these are unobserved variables. Residual error we talked about that time. Now it has to have its own error. So we have to bring it here. So this is it. Now the lines, the connection among them. So all of these ones are determinants for the AC. So we need to use this arrow. This arrow, bring it from this place to AC. Bring this one also from this place to AC. They are the one determining it. You don't need to be somebody from art before you know how to use this arrow. It's very easy. The result is what is important. All these ones are unobserved values. So I'm going to estimate now. I think that's the only thing remaining to estimate. Do estimation. So you can see when you put your mouse here, I'm using mouse.
Right, love the church.
Hello.
Can you imagine how many people that are in the church?
Hello?
Then it says, woman,
hello?
Submit.
Hello.
Hello?
Hello.
Please continue, Dr. Baja.
Hello. Please. Okay. Now, if you can hear me, please, I want to round up very soon. Now, this is when you click, when you know all these tools are here. Just click on each of these here. This we have calculate estimate. Here is a analysis property. Let me look at the analysis property. We want it to be maximum likelihood. Now, estimate means an intercept. Generalize least square. The output, minimization history, standardized estimate, squared multiple correlation. All of this depends on what you want to achieve. Then, here we want to estimate, calculate estimate. Nine variables are unnamed. Okay, 9 variables. All of these are not named. Yes, all the unobserved. How do you do that? Just go to plugin. Then name unobserved variables. They have been named. You can see E1. These are errors, but here it is called unobserved. See errors to this place. So let's now estimate, calculate the estimate. Proceed with analysis. Okay, we have not name it. Let's call it PSSN. Call it anything. PSSN data. So it's estimating it. Can see it has finished estimation. You now view the output. Let's view the see the output. Can we see? Can we see? Can we see? See. These are results. These are estimates. All this one, time enough maybe to go into. I will just show us some of detail of this. We can write a lot of things from this. This is unstandardized estimate. Make it standardized now. Can see that's why all the 1 plus all of them, you have used standard deviation. So here they are now less down. How do you now know whether this model is acceptable or not? Whether it can be used for, is it going to be the last one? If it's not satisfying the laid down rules for acceptance, just like goodness of fit we did the other time, there are things you need to do. You need to readjust. You need to modify. by connecting all of these neurons together, we can connect them together and see the improvement. Now, do you see the improvement? Okay, let's see detail of all of this. You can see the relationship now 0.5, 0.9, even from the error here, from each of the variables. You can see all of them. Now, do you see detail? Come here. Look at analysis properties. You see the one that you see view text. When you view on text, see. These are results. Analysis summary. Let me click on it. Where I'm going is just the time is this. Okay. Notes for groups, variable summary. These are the variables. Parameter summary. You can see. And where I'm going is model fit. Look at the model fit. See. Now, the rule is that this is chi-square divided by degree of freedom must not be too high. It shouldn't be too high. It should be less than 5. That's the rule. This one should be less than 5. So, because you don't just look at p-value and say, well, this is significant. No, you go on. Dividing this by this must be less than 5. Now, this one, all these values already, this is baseline comparison. We have NFI, we have parsimony adjusted measures, all of them. Now, all of them, they have their rules. You have AIC, BCC. Let me quickly just explain some of them before, because that's the last one. The AG, the NFI, that's normal fit index. The RFI, the IFI is an incremental fit model index. All of them. All of these must be greater than 0.9. And here, see, they must be 0.9 or above. We'll see them. They are very, very low. It means this will not give us the best model. Where we have RMS, RS, this one is root mean square error of approximation, RMSE. And the rule is that this one also should be greater than 0.1, though it passes it. What about the remaining one on top? So it means we can go back and do some adjustment on the model, the relationship. How do we do that? Let me go back. All we need to do is just clicking on that. PSSN data, it's gone. We now come here, pick this. See, we can begin to look for relationship among this. See, just try and link the hostel condition with classroom condition, whether it's going to have all these things we are doing graphically. They are serious work if you want to do it using the normal way of doing all these things. All those things I did, I was testing each of them in Loglinia, but here you just draw and go to do it mathematically for you behind. So now what are you going to do now? You do the estimate again. Okay, we'll see with the analysis. And let's see the result now. It has done it again. And let's see whether it's going to have effect on it. Check here. Okay, so already it has done it somewhere. Let's go to the model fit. Though it has improved it, it's improving gradually. This one can take you some hours or days before you arrive at. That's why we normally have many models before we now arrive at making valid decision according to the topic of this webinar. I want to stop here. You have already spent more than 1.5 hours. I want to stop here in case we have some questions and maybe addition. Thank you very much. Dr. Yamaki.
Yeah, thank you, Dr. Ajayo, for your presentation.
Yes, sir.
You will agree with me that you have gone to a great mile, and we have learned so many new things from your presentation. I personally enjoyed your presentation. I know that there will be some questions from the participants, and I can see a hand raised up. That is Karim Sahid. You have raised your hand up. Yes. If you have any question, I think you can go ahead and ask your question.
Okay, thank you very much, sir. Okay. And thanks to the presenter, we really appreciate the webinar. So my question is, sometimes in R, whenever you are working with R and maybe you want to download a library, maybe you want to work with a library, for example, the
Hello?
ggplot library, it doesn't work. Hello, can you hear
Hello?
me?
Yes, yes, go ahead.
Hello, can you hear me?
Oh,
Okay,
Maybe the
so yes, in R. Hello?
Karim, go ahead. Karim, go ahead.
Oh, okay. So like the packages, they don't work in some versions of R. I don't know if the presenter citing like using ggplot as example, so it doesn't work in some R packages. So I don't know, maybe he has encountered such problem in the past, and maybe he will tell us how he used to go about it. So thanks. And the second question is the package is using for the graphical analysis. I don't can you please tell us the name and how to get it? Thanks.
Okay, Dr. Isaac Ajao, can you respond to his questions?
Yes, sir. I was offline when the first question was asked, but I had the second question. I think the second question is the kind of software I use for the last demonstration.
Okay, please let me ask the first question, sir.
Okay, ask the first question again, please.
Okay, the first question is I said while working with R, like sometimes we need to install some libraries or some packages.
Yes.
Well, we do encounter problem. For example, I now cite ggplot as example. So it doesn't work on some of the R versions. So I don't know if you had come across such a problem, and please, how do you go about it? Like for example, I was trying to install ggplot on my R Studio some days ago, but it doesn't work. I went to download almost all the versions of R, but it doesn't work. So I don't know if you are used to encountering such a problem, and please, how do you go about it? So that's my first question, sir. Thanks.
Okay, let me respond to that first. You see, it's a common problem. Honestly, even it happened to me last week. I don't know whether the person that I discussed with that problem with, I don't know whether it's online also. It took me 2 days. So because our work, as you have to be online. Most time, the latest package you want to use has to be, if you have it on your system, has to be updated, because every day new feature come out. So in fact, at times you have to uninstall your HAR and reinstall your HAR studio. You understand? So by the time that's why data, you must not be, for you to continue to use HAR, to enjoy HAR, you must always have data. Not say because HAR is not like other software that they say I've downloaded this, that's all. MATLAB is on my system. You don't need to. I have SPSS. No, HAR, you have to be online and be very careful, because the code you use last month, the same code you use after 2 or 3 months, the chart or the result that you want to have will have some features again. It's because you have updated your own. So update must be done always. That's just it. You uninstall and install until you get it. It's a common phenomenon. Then the second one, which one did I use for the software I use? It is called IBM SPSS Amos.
Okay.
IBM SPSS Amos. So
okay, IBM
that's
SPSS.
yes, it come, just download SPSS, but you make sure that because it's not every SPSS that has it. It's a module,
Okay.
it's come with it. It's like a how do I call this? It's like a plugin. When you have another feature coming up on your Excel, you can do Excel. You have Excel add-ins.
Yes.
Just like that for so I think I've answered that.
Okay, thank you very much, sir.
Thank you very much. Yeah, thank you. I can also see another hand raised up. That is Mumini. Mumini, can you go ahead and ask your question? Mumuni Sahid. Okay, maybe Mumuni is not ready to ask his question. Can we have any other question?
You should unmute now, Mumuni.
But he should have to hear me now. If he's ready, he will go ahead with his question.
I think he's talking to Said. Said has not muted himself. That's why.
Okay.
Okay. That's
then
why.
let's Omo. I can see Omo raising his hand. Can you ask your question? Omo, go ahead and ask your question. Hello. Omo. Yes, go ahead.
Mr. Omo.
Omo, can you go ahead and ask your question? Okay, Mohammed Tahir, you are raising your hand. Can you go ahead, Mohammed Tahir?
Yes. Thanks so much, Professor Gowa.
Yes.
And the presenter, may God bless you both. My own question is this. This pictorial analysis that you've been doing using the AMOS, this is my first time of using it. This is my first time of seeing it. What is the advantage of this over the normal analysis that we normally do using SPSS, R, and others?
Yes. I see a lot of advantages. You see, one thing there is this parts diagram that is giving you. You can see it's only time does not permit, we don't have time enough. I would have shown us as we are increasing the parts, showing the interrelationship among the variables. You will see the result being changed. If you are to do it, I show you how to do log linear or hard. That one I just showed to you. If I'm to be doing it here, we can't finish it today because each model at time take you 1 hour, 3 hours before you now test goodness of fit. You know what I'm talking about. Before you can see all those, the R square, see the deviance. But here, all you need to do is just, people that are using this. Let me tell you one thing. People that are using AMOS, many of them are not professional statisticians. So they are looking for experts that's done in such a way that just use simple method, you will achieve your aim. So the chart, the arrows that's connecting one variable to the other, is making it more understandable for people that are not in our field. Once they see it, they know what to do. Then you will quickly get your results. It's just a matter of changing that and following the rules. Then you're going to get your model. Then the result behind, they're going to show you that the one I showed to you when I went to text. You see all those results, very detailed. So you can get out all detail in hand, the number of code you're going to write. So that's what make it, and it's much more appreciated by people outside. I think I'll start your question.
Okay, I think that is good. Thank you very much. Let's hear from Omo this time. Omo, are you ready to ask your question? Hello, Omo.
He has not muted himself.
Okay, now Isa Abdul Mumuni, is it? Isa, can you go ahead now?
Yeah, good afternoon. I'm close to the organizer and the presenter. Can you hear me, sir?
Yes,
yes,
very
sir.
well. Yes.
Can you hear me? Yeah. So yes, mine is a kind of an appeal. Yeah, mine is a kind of an appeal. I have attended the seminar like about two or one of the seminars thereabouts. And what we get after the seminar was has always been maybe either the recordings or just one of the material. We don't always get the complete passion of material. So I want to appeal to the presenter and the organizer. Please, we need this so first we can do the reading on our own and get better understanding of the seminar. Like the hard code normally used during the seminar, the soft copy of the material and the recording. As you think you can get that, it go a long way to enrich us more. That's just my
okay. Yes.
Okay, noted. We'll look into that. Thank you. Dr. Yamaki. Okay.
Yeah, thank you, sir. Well, some of it will be comments, some will be response to some of the requests in terms of materials, and the video is online. You can access it on YouTube. As you are looking at listening to this call, you can click on the YouTube menu that is on top of your screen, you get the link directly to YouTube. So you can get all that has been discussed today. Secondly, I wouldn't know the data privacy mechanism that is associated with what Dr. Ajao has used today. But if it is data that can go public, I would advise that you help us put it in a repository, sort of, since you needed the codes, it will be very easy for us to follow it like that, so that we can circulate it widely to members of our society. I wouldn't know if you'll be able to do that. Okay, so that's on the comment side. Then on the question side, well, I think when you were talking about these data types, especially the qualitativeness, and you mentioned in-depth in that interview, and you didn't mention focus group discussion. I'd like to ask if that was not needful for the explanation that we had today. That's one. Then two,
focus group discussion.
Yeah, focus group discussions.
Hello?
Yes, I'm with you.
Yes.
Yeah. As part
focus
of
group discussion.
Let him finish before you respond. Just allow him to finish. So,
hello, sir.
Go ahead. Yes, go ahead.
Okay, Ajao, are you with me?
Yes, sir.
Yes, you are presented.
I'm with you. Okay.
Focus group discussion. Let me just finish the question so that we can respond together.
Hello?
Okay.
Ajao, did you hear that? Let him finish the question. Let him finish the question, then you can respond. So go ahead, Dr. Yamaki.
Okay.
So you will respond on the focus group discussion. Another thing that I also notice is that oftentimes during our classes, our survey classes, in our respective university where statistics is taught, we often say we have probabilistic sampling and non-probabilistic sampling. And when we come to the examples under non-probabilistic sampling, we often mention judgmental, quota, and all that. And we fail to talk about snowballing and response-driven sampling, which are methods that is being used, especially by these sociologists and others in the sister departments. What do you have to say about this, especially as it relates to some component of a comparative factor analysis that you have mentioned? Then the last thing is that do we have an equivalent package on HAL that can do what Amos is currently doing? I know that there are strong relationship between comparative factor analysis, path analysis, and mediation analysis. And I've also come across a package called Medflex, which is going to be extremely useful for mediation analysis. I wouldn't know what your disposition is to this. Thank you.
Okay. Now let me start from the last one. The one I use here, even on Harris, I've done something similar. All we need to do is just to install the package called SEM. That is a structural equation modeling, and the kind of that particular part chart I gave, they are almost the same. But the reason why I chose Amos for this particular training is because of his ease of use. It's very easy to use, be better understood by people that you are working for. So is then on the issue of there, I will maybe mention that one and write it in the material I'm going to send. Then the comparative analysis we talk about also. The people prefer, the kind of data, before I now move on to focus group discussion, we want to be using the one that is very easy for us, not that we don't know. Even we want to teach our students all these probabilities and non-probabilistic method. They know, and we all know, but one at times, for convenience, when you ask students to say, okay, this one we are going to use multi-stage sampling. you're going to use cluster, you're going to use this and that. The students, even when you have not even talked, already some of them are already complaining that, Oga, you want me to use this, move to that, how would I divide them? How will I do this? So eventually we keep using the same method. Whereas there are so many other methods, there are so many sampling techniques, so many of them as you have mentioned. But we are using the one that is very convenient, and we lecturers accept it from them. And that's why, and when you don't use correct sampling method, sampling technique, or collection data method, correct one, you can't get a valid decision. So we only need to encourage ourselves to explore more of this method and encourage, I don't want to say force the students, even ourselves, even our own personal researches. Use it, like the one I did on Amos now. I did it myself and I said, okay, that of Loglinia, let me do it and be part of this work. So if we are interested, we do it, and by the time the student already, many of the things we do for the students, the best way is to teach them, force them to know it because we know it. But when we don't do research, we are giving our students something to go and do, and we ourselves, we have not even explored it. How do we now know whether what they are bringing is correct or not? That's where the problem is. So eventually they will do whatever thing they know and submit it and go. So, but if we, as we are giving to them, we are doing it behind. So they will know that the organ knows this, they will go and even if they are going to, it's going to take them sleepless night, they are bringing that in. So I think that's my view on that. Not that we don't know that they exist, but we are looking for the one that is very easy and convenient to do the right thing. Then on the focus group discussion, many here we don't use it. Even what we are, there's a particular group where you need to maybe for a particular research, and you come together, you discuss it, and whatever thing you come up there is going to form part of your data, and that takes you to good, because we are coming back together again to discuss it, and whatever thing you bring from that place is going to help you in the analysis. That thing is part of it, but it's not being practiced here. Though, in the kind of work we do, many of us work to come up with paper for promotion. Only few people have interest in research. The research many people do is to get paper and to get promotion and go away. Otherwise, there's nothing bad in making use of this method. Gather people together that that has to do with the research, your research topic, and you focus that, discuss it, and bring out ideas, and you work on it. But it doesn't really work, because how do we think about so many things? A lot of things are standing against us. The money, the convenience, electricity, internet, people begin to complain. The group members may not be, the day you even fix for them to be met, to get data from them, or for them to come back and discuss on particular thing, may not hold because of so many factors that are standing against us. So that's what I have on that.
Okay. Dr. Yamakin, are you okay with his response?
Yeah, of course. I'm okay with Dr. Ajao's. He has done brilliantly well today, and that's fantastic. The last thing that I think he missed out is the materials that our members have been asking for. Since, yes, and we get it and get some. If the data is not something you may want to share, then you can use another data to demonstrate it. Okay.
Okay. I will do that.
So that we can relate with it. Yes. You'll be able to produce all those tables and graphs and all that.
Yes, I will do that.
That's what some of our members have been asking. Thank you so much.
I will do that.
Thank you, Dr. Yamakin, and thank you, Dr. Isaac, for the response you have given. Very good. The next person I can see the hand raised up is Adebowale. Adebowale, can you go ahead and ask your question?
Yes, thank you, sir. Thank you, Dr. Ajao, for the educative program, which you have just allowed us to witness. No doubt about that. I've benefited personally have benefited immensely. But my question, sir, is this. I just stumbled on this program. And the first question is that, does one require a degree for him to become a member of this body? That's question number one. Then secondly, does the library, that is the package, IBMSS, SPSS package, AMOS, come with a subscription? If that is the case, please, how do we go about that? These are my questions.
Okay, Dr. Isaac, can you respond to his questions?
Yes, sir.
Okay.
Well, the last question that says, does it come with subscription? You know, all the software, we only have and maybe some other software that are free. Many of other software we use are not free. We only get them through, the means we normally get all this software. So, but to get IBM SPSS AMOS, you have to, by the time you are downloading it, whoever is giving to you, make sure it's the one that has this particular one. Because it's not every, even version 25 doesn't have it. So the version 23 I'm using, I don't know whether version 25 or 26 as it, I don't know, but 23 that I use now, I just noticed that it's the only one that has it. Other ones, it's just the normal SPSS. It doesn't have it. So if you are interested, you have to check that version 23. Go and check version 23. And it's not every version 23 that has it. That's another thing. You have to check behind. Does your own version 23 has it? So then on the condition for becoming a member of this society, if you are not from statistics, you are not from mathematics, the only thing you can enjoy is what you are enjoying now.
I think the simple answer is that you must have a degree or HND. That's
in statistics. In statistics.
Mathematics, yes.
What about we in the management, accounting? Can't we be given that opportunity?
Yeah, that's why it is professional. I think you must have that professional degree in statistics or mathematics. For now, yes.
And that's why we are organizing this kind of thing for you people.
Okay. Very instructive.
So we are doing it every month. Another one coming up next month. Every month. The last Thursday of the month.
Yeah. Thank you very much. Can we
go
ahead?
Okay, thank you, sir.
Yes, thank you. Omo, are you now ready to ask your question?
Yes, I'm ready.
Omo? Okay, Omo is not ready to ask his question. Let's go.
Dr. Adebo, can you hear me?
He has submitted himself.
Hello.
Please, let Dr. Oyamake talk to Dr. Adebo.
Okay, you can go ahead. Go ahead, Dr. Oyamake. Hello. Dr. Oyamake, can you go ahead?
Somebody is now the host. Dr. Oyamake, what happened to you? I don't think it's online. He's trying to say something very, very important concerning becoming a member.
Yeah.
Okay. I think Dr. Yabaki wanted to say something concerning the membership.
Yes, very important.
And I believe Dr. Ajao has already answered the question. And Professor Go as well. At least you must have a degree or HND in statistics, in mathematics, before you can become a member. So, and if you want to attend our conference, you will register as, you will pay for the conference as well.
Okay.
But not as a member, except you have the degree or the HND.
HND in statistics.
Yes. So
it's good. Come and be part of us.
I think
Thank you, my doctor. Thank you, my doctor. I would like to be part of you. Thanks so much.
Okay.
Appreciate it. Okay, bye.
Bye.
So,
okay, we have many hands raised up.
So many hands on top.
Anthony Peter, are you ready to ask your question? Anthony Peter, you are not ready.
I'm ready.
Ware Abraham, are you ready?
I'm ready.
Go ahead.
Good afternoon, sir, in the house. I really enjoyed the presentation and everybody in the house. But it seems I'm just a layman in this field. I'm an architect. I'm an architect. So the presenter is my very good friend. I just say, let me peep in to see what you are doing. I've really enjoyed the lecture, but actually what I wanted to get from the whole thing is, can we, the last four people that ask questions have emphasized on it, the issue of the materials. Maybe I will still hold on to it and then learn more than what I've just learned from the line here. Thank you.
Okay, we'll work it out and make whatever is possible available to you.
Thank you. Do that.
Thank you very much.
Okay, thank you. Next person, is it Ware Abraham? You ask your question, go ahead.
Okay, sir. I would like to talk about those people that have been talking about the materials. Because as the program is going on, as the lecture is going on, some of us find it's difficult because the network is just fluctuating. Maybe you can get a video of the video record, the screen record of the lecture together with the material so it can help us better.
Okay, we've had you. We're going to look into that. Okay?
All right, sir.
Is that okay? Now, next is Didion Udofia. Your question, please.
Thank you so much, Prof. Thank you, sir. It's a wonderful time. I think I've been able to understand a lot of things as regarding AMOS software. So thank you so much, sir. So I want to say, I don't know, I think it would be easier for Dr. Ajao to share the material through this link here. So members can easily just download it immediately from there and to sit down and start sharing through our mails. If you can just share it here, using the share button, that would be better. People can just quickly, as soon as possible, just download it here directly. Thank you so much. That's over from my answer. Thank you.
Okay, thank you. We equally consider that. Going down, I think we have heard from Karim, we have heard from Toheb. Enoch Kure. Enoch Kure, can you ask your question? Enoch.
Yeah, good afternoon, Prof. Good evening, Prof. I really appreciate that. Hello?
Yeah, we are hearing you.
Yeah, I really appreciate this program, and I'm actually from mathematics education. I did my first degree in mathematics education, my master's in mathematics education, and I did my registration and tried to do the registration online of Professional Statistician Society of Nigeria. I want to make the payment. I don't know if I'm permitted to make the payment to become a member. Yes, sir.
Of course, you can make the payment through online, please.
I am from mathematics education. Can I become
At least
a member?
you have a mathematics background. It's still mathematics anyway.
Okay.
So
thank
please
you
go
very
ahead
much.
and make your payments, please.
Okay, thank you very much.
You are welcome.
Okay, are you okay? So next person is Formula. Formula, you are raising your hand. Can you ask your question? Formula. Formula is not ready. Christopher Abraham.
Hello.
Hello.
Yeah, good afternoon. Thank you, Mr. Okegubin, presenter and organizer, and every participant here. I really enjoyed the training or the webinar as presented so far. But my own question is on the Kobo tool that was introduced. I think I've had opportunities of using the Kobo tool, but my challenge, which I would want, if possible, to just address a little, if time would not permit, is regarding the collection, the upload of the data from the Excel to the Kobo tool. linking those choices, because there are questions sometimes relating. My challenge with it is relating the Excel data with the Kobo tool. After preparing
Sorry,
some of
please, can you collect the email address of Isaac, Dr. Isaac, the presenter, so that you can get more information from him, because that is very personal. Okay. You know, the question you are trying to ask is very personal.
Okay.
Is that okay?
Yes. Okay. Thank you.
You collect his email and then relate with him. He will help you more. Okay.
Yes, sir.
All right. The next person is Cyril. Cyril Romone. Cyril, can you ask your question?
When you did now, familiar terrain.
We're not hearing you very well, Cyril.
And you're territory again now.
Yes.
Hello.
Yeah, go ahead.
Hello, sir. Hello. Good afternoon, sir.
Good afternoon.
I'm very happy concerning the presentation, because I've been following it, and I'm really blessed, and it has improved my knowledge of statistics. But the issue of I want to discuss the issue of registration. I think I paid online. I did the registration online, and I paid since September 27th. And I've tried to reach Professor Yaya. I've not been able to get to him. So, but from then I'll be checking the registration. The portal is saying pending. So since September 27th. So I said, let me raise up the issue now. I have my first degree in mathematics, my second degree in mathematics, and I have a PhD also in applied mathematics. Thank you, sir.
Okay.
In a situation like that, maybe I should just answer that question, please. Professor Ogwewo, please permit me to answer the question, please.
Go ahead.
Okay, concerning that, you don't have any problem. The only thing you can do now is go back to your portal,
I will
right?
say
Go back to your portal, then send a message to the admin. Are you getting it?
I have done that, man. I have done that. I have sent the message to the
there's
admin.
No response from the admin.
Hello.
There should be. Professor Yaya will attend to you, of course, now. Okay, Professor Yaya is there. Okay. Over to Professor Yaya.
Hello. Yes,
Hi, we can
I was
hear you,
about
sir.
saying that. Thank you very
Yes,
much.
Go ahead.
Well done, Prof. And
well done, my president.
You are welcome, sir.
Thank you, sir. Thank you for the good work that you have been doing. I have epileptic power here, so I've been having running battle joining consistent since we started.
Welcome, Prof. Sir.
Thank you very much. Thank you, Dr. Yamakentu, for the IT job there. Thank you very much. Like I used to tell our new prospective members, it is not automatic that you register just a month, within a month, and you want our certificate. That doesn't confirm membership of our society on you. You register last month and you want the certificate. Before you can become a member, you must have been participating in our activities, like conference, like workshops, like this one you are doing for some time. If you look at the message that you have on your portal, it will tell you that your membership is being reviewed. Okay, and you are going to get back to you when we felt you have satisfied all the necessary requirements to become a member. So paying money to us and wanting the certificate is not the way to go for a professional body like the PSSN. I've said this severally. What we have been doing is to just be magnanimous to our new members, so that because we knew that some of you are in the polytechnics, some of you are in the colleges of education, some of you are in the universities that may want to use this certificate for promotion. So we bend some rules at some levels, but it doesn't make it a sacrosanct thing that you must have the certificate immediately. You pay 5,000 naira and then you become a member based on that. That is not the way to be a member. Okay. What you are doing, I like that you are joining this. What you are doing now and attending our conferences
attending the becoming workshops and other things like that. After a year, if our activities have been an annual thing, before you can have a certificate of a society, it is when you go to the conference and you register, you pay conference and like that, then they issue you a certificate at the conference. But now PSSN have blazed the trail to ensure that we have online arrangement for our people to join, to register online. Then we review your credentials, then we approve the certificate for you and convert to you our membership. So that doesn't make it automatic, okay? So just bear with us. We are reviewing those that we have approved some, even last 4 or 5 weeks, okay? If you are still pending, you just have to bear with us until we are through with you and we are satisfied and we approve your certificate, okay? That is the message for the questioner that he has registered and is giving the response, the pending response on the portal. So we have seen your application, but it will be approved at the appropriate time. Just bear with us. Thank you.
Yeah, thank you, Prof. Thank you. I think he must have had. So please make effort to attend the next conference so that we'll know that you are really interested in being a professional member. Okay. Okay, I think we'll now go through those who have raised their hands quickly so that I think we're running short of time. The next is Osai Henry. Osai, can you ask your question quickly?
Okay. Yeah, firstly, let me say thank you to the presenter, Mr. Dr. Ajao. Thank you, sir, my supervisor. The professor, I've just dealt with my first question. Can you hear me, sir?
Yes, we are hearing you.
Okay, Professor, I've just dealt with my first question because I want to ask him, this is my first time of joining this webinar. And I want to ask if the process to join the society or the profession as a member. So I would like that to be well stipulated on the gradual process. You have said part of it, and where should I register? If I want to register, is there a site or what do I do? That's my first question. And again, I work as a logistic analyst, and these days I've been working with Python. And I think on R, when I was in school, I learned a little about R. So this is my first time of seeing R in a bigger way. And I want to ask now, Python and R, now, sir, do you feel maybe learning more about Python is better, or I should still go on with learning and knowing more about R? Because most time we deal with display of visual, all these are visual charts in terms of lead time, the movement of our goods are going here and there. So most time we use R and Python and Excel. So, sir, what will you say about this Python and R? Can you get me, sir?
Okay.
Yeah, okay. Dr. Jao, can you respond to his question?
Okay. Thank you, Henry. You have made mention of it. The kind of you have to register is very easy. You can. My email address is there, and the president, Professor has talked about it. We can relate later on that. Very easy. But on R and Python, I use Python also. But I found out that Python, when it comes to advanced statistics, you can't go near. R is just specifically for statistical computing alone. But Python now, you can see that it's more web-based than R. You can be working on Python, and it will be generated to another place like that, the way it's been done. So before all the pandas you install on R, on Python, it's not like that on R. So it is for you to now pick the one that will be more relevant to your work. Either Python will solve your problem better, or R. But if you are into academics, you understand, if you want to really go into academics, you want to do the work of an academics, you will need R. But when it comes to other ones that you just mentioned now, if you prefer, because when it comes to graphics also, you may be able to relate with it better than R. You understand? So it is in your hand now to now choose which one will answer your, but it's better because you are a statistician. And as you are working, people can say, okay, you did statistics, thank God for you, and they come to you. So it's better you go and learn. In addition, it's going to be additional advantage for you. You understand?
All right.
So that's
thank you very much.
Thank you. Thank you, Dr. Isaac. I think we have gone through all those who raised their hands. I don't know whether there's anybody who raised his hand and is here to be responded to.
Not a problem.
Yes, yeah, President.
Thank you. Thank you very much, Professor Ngo, for this beautiful coordination. Just want to, because I have another engagement now, maybe offline now, in a couple of minutes. So I have to admonish our new members to keep joining our webinar, especially our monthly webinar. The society is very magnanimous to ensure that we accept as many members as possible at any level, at any time. So unlike when it used to be the manual registration, where you have to join at the end of at the point of registering for the conference each year, that has been relaxed. That is why you can register any time of the year. So please take that advantage to be joining the webinar. So you are going to be monitoring that to really see that you are committed. Because the answer of what this webinar thing is to ensure that our members benefit maximally as professional. So that is the thing, because we are putting a lot of effort into it. Since we started, you can see that the series of presenters that we have been having, they have been trying to do justice to the topic that they are discussing. And it takes time, efforts to prepare those materials, and their time to present this. So we have to justify and say thank you by making sure that the message that's across to us are well situated, very well in us. So that is the thing. Thank you very much. The participation today is very encouraging, and I want us to do more. Next time we're having this, I want to thank Dr. Yamake and other crew members that have been here, other executive members that are here. I can see Dr. Yamaga and Mrs. Acha.
Thank you very much.
Thank you very much. I want to say this, that finally that the time for the webinar is within 2 and 4. So we because of we may have some other things to do. So yes, it's good that we have people that are ready to make inquiry, comments and there. Let us try to manage our comments very short, so that we can do everything within the 2 hours time frame, and have to go and do some other things that are.
Yes.
Thank you very much, Paul.
Yes, thank you very much, sir. Thank you. I think it's well taken. Just 2 comments or do I say questions for Ajao? Ajao, please, are you ready to respond? I just have 2 questions.
Okay, sir.
Now, the number one is when you are enumerating the methods for primary quantitative data methods.
Okay.
I didn't hear you mention data collected through experimentation. And,
okay.
I would like to know, where did you classify that method now?
Okay, experimentation.
Yes, experimentation.
Experimentation. Experimentation should be primary.
Yes, but when you are enumerating different areas, how you can collect your data, experimentation, presumably should be one of the ways of collecting primary data. But I didn't see it, in all the. Okay. I didn't see. That's why.
Where did I omit it? People from science, biosciences, chemistry, physics. I'm very sorry. It's supposed to be there, even from engineering, because it's part of the way we collect data. Experimentation. You go to the lab and collect it. Even we have statistical lab. You do all of those things. So it's part of. Sorry for the omission. It's part of the data collection method.
Okay, thank you. Then the last comment now. I would like to have at least 1 or 2 examples of the kind of data you collect using this COBO method. It is internet-based, but can you give us, a typical research that will lead you into collecting one kind of data for using this COBO method?
Okay. The one I took part, it has to do with UNICEF.
Okay.
For Ekiti State. So, for example, now the one we did there was about measuring poverty. So, if you want to cover people in rural area, people that are in remote places, is very good. You know that what WHO is spending its money on? Women, children, especially on health. You want to improve their lot also. So you just send, you have to train enumerators, I help them to install this thing on their mobile app and ask them, tell them where to go. Everything they are doing is coming onto your own database. So you have to train them, let them know. Then if it's going to be, anytime you want to do anything that's going to cover wide range, is very good. It's not good for something that is just within an environment. But if it has to cut across a whole state or a whole nation, that's where CompConnect is being used. I want to see a good result. That's good. I think I've answered you, sir. Prof, sir.
Dr. Ajao.
Yes, sir.
Thank you very much for the beautiful presentation. Sorry, it's an oversight. I wanted to acknowledge you and especially these depths you have taken us into in terms of your topic looks simple, but your analysis look more critical. I like that. And our people really enjoy your presentation. You see what people are doing especially in non-statistician. There are a lot of packages now that are coming up to simplify analysis. We want to call it analysis made easy, so that they play down on the methodological aspect of it. But how to admonish those of us that are really the professionals, we must know all these theories. That is very important. We must know the theories behind the results being given us by the packages. Okay? Yeah, so that is very important. So in case you want to make some critical research into some of these methodologies, unless you understand the methodology, that's where you can compare, you can critique, you can. So therefore, that marks the difference between the professional statistician, and the statistics users.
Yes.
Okay. So it could be easier for anybody in the management to use IBM, SPSS, EMOS, even if it's not a statistician, but he may not be able to understand the theoretical behind the result that is being produced.
Exactly.
So, but it's important, it is incumbent on us, we the statistician, to really don't behave like ordinary users of these packages. We must understand the methodologies. But nonetheless, it is important that we also have to move with trend by ensuring that we are versatile in the usage of all these new packages, in data visualization and result presentations. It's very important. That area alone is what some people are selling these days now. And we must not be found wanting. That is the message that Dr. Ajao is trying to pass across to us. Once again, I thank you very much for your presentation.
Thank you.
Thank
Mr.
you very
President.
much, Dr. Ajao, for having you around. God bless you. Brilliant presentation. I really enjoy everything. But don't forget about the slides. Many people are asking for the slides, please.
All right.
Okay. Thank you.
So finally,
Prof is back.
Yes, it was just a brief, network problem. So I want to thank everybody for active participation in this webinar. And I want to thank especially Dr. Ajao for the explosive and well thought out presentation. We have all enjoyed ourselves. We have learned so much from his presentation. So we are looking forward to next month's presentation. And till that time, I think I will say goodbye and Happy New Year to everyone.
Bye-bye. Happy New Year in advance.
Bye. Yeah, bye-bye.
Bye.
Yeah, bye.
Yes. All right.
Okay, bye-bye.
Bye-bye.
Yeah, thank you, sir.
Yeah, bye.
Dr. Ajao.